Good evening. Our focus today is on whole interval time, sampling and its inherent tendencies to underestimate or overestimate behaviors. Whole interval time sampling is a method used in behavioral observation, where the occurrence of a behavior is only recorded if it happens throughout the entire interval. It can lead to an underestimate of behavior, since shorter instances that don't span the full interval aren't counted. For example, if we're measuring instances of hand raising in a classroom setting, and our interval is 1 minute, a student's quick hand raise may be overlooked if it doesn't persist for the whole minute. Here is another example. If a student starts studying for 8 minutes, but stops for 1 minute in the middle of the interval before resuming studying for the remaining minute, using whole interval time, sampling might underestimate the time spent studying, since the behavior of interest studying did not occur for the entire interval. It would be recorded as absent, leading to an underestimate of the actual time spent studying. On the other hand, it might overestimate behaviors that are continuous of high frequency, since the once initiated, the presence of the behavior is marked for the whole interval, despite any momentary pauses. Imagine there's a student named Sarah, who frequently flips through the pages of her book during the reading activity, but only spends a fraction of the time actually reading the text. However, during each 5-minute interval, there are moments when Sarah appears to be engaged with her book, even though she may not be actively reading. Since whole interval time sampling counts any engagement with the behavior during the interval, Sarah's brief moments of appearing engaged with her book, such as holding it open and looking at the pages, would be recorded as reading for the entire interval. Throughout the activity, Sarah's behavior of flipping through the book without actually reading may result in an overestimation of her reading time, because whole interval time sampling does not distinguish between active reading and passive engagement with the material. As a result, the method may overestimate the extent to which Sarah is actively engaged in reading during the observation period. So, in this example, whole interval time sampling would overestimate Sarah's continuous writing behavior, because it doesn't capture the finer details of her behavior, such as brief pauses or breaks she might take during the writing exercise. To mitigate these issues and provide a more accurate measure, using interresponse times ERT, which is the time between the end of one response and the beginning of the next. To prevent underestimation, shorter intervals can be used so that brief behaviors are more likely to be captured within an interval. For instance, decreasing the interval to 10 seconds while observing hand raising ensures even brief instances are included. In the case of overestimation, incorporating a rule that marks an interval only if the behavior occurs at both the beginning and the end of the interval can help account for natural breaks in continuous behavior. In summary, whole interval time sampling may lead to underestimation when behaviors are frequent, but brief, and overestimation when behaviors are continuous but sporadic. Using ERT effectively requires customizing interval lengths and observation techniques to the specific behaviors being measured. The goal is always precise data that truly reflects what's happening. That's it for now. Stay tuned for more insights. If you like this video, please press like and subscribe channel. Thanks for watching.